Now we are going to end the interesting result. So the theorem states that x and y are, if x and y are non-best spaces, x and y are non-best spaces, f from x to y which will be linear, x from x to y is linear. If f of all in CLXY, f is in CLXY, if xn weakly converges to x, we know what is weakly converges. Weakly converges to x in x, then f of xn converges to f of x. F of xn converges to f of x in y. So this is our first argument. X be a non-best, x and y are non-best spaces. F from x to y be linear. F is a compact linear map from x to y. And if xn weakly converges to x, then f of xn converges to f of x in y. How? So we know that xn weakly converges to x. So that means by the definition of weakly convergence, then secant xn is bounded. Secant xn is a bounded secant in x. It's a bounded sequence in x. Okay. Now to show that f of xn converges to f of x in y. That's our requirement. If possible, f of xn does not converge to f of x. F of xn does not converge to f of x means there exists some epsilon is positive. There exists and a subsequence xnj. There's a subsequence of xn such that norm or modulus of norm f of xnj minus f of x greater than or equals some epsilon for all j equals 1, 2, 3. Why? Because f of xn does not converge to f of x. When f of xn does not converge to f of x, we can find out an xnj, that is the subsequence of xn, which satisfies this condition. There is no f of xnj minus f of x greater than or equal some epsilon for j is 1, 2, 3, etc. Okay. But we know f is in CLXY. F is in CLXY means f is a compact linear map from x to y. So, and we know that what is xn? Xn is a bounded sequence in x, there is no xn is less than alpha. For some alpha is positive. Then we know that since f of xn or f of xnj, every subsequence of f of xn, that is f of xnj, then has a convergent subsequence in y. So f of xnj has a convergent subsequence, so let us say j be a subsequence of sequence xnj. Then we know that this f of zj converges to some y in capital Y. Why? Because of the compactness of f. Xn is a bounded sequence. We know this result. Then xnj be a bounded. Since xn is a bounded, surely this xnj, sequence xnj is also a bounded sequence in x. And f is in CLXY. For any bounded sequence xnj, there exists a subsequence j of xnj such that f of zj, sequence f of zj has a convergent subsequence in y. That is because of our research. Okay. So that means f of zj converges to some y in y. But f of xnj minus f of x of this one. So we can f of xnj has a convergent subsequence f of zj converges to y. So this norm becomes norm y minus f of x greater than or equals epsilon. Okay. Norm y minus f of x greater than or equals epsilon means y strictly differs from f of x. Okay? Yes. On the other hand, if y dash fall in y dash, then what is y dash composition f? That will fall in x dash. Okay, y dash is in y dash. f from x to y, then y dash composition f falling where. That's simply expression. And x and j converges to, we know that x and weakly converges to x. X and j be a subsequence of x and surely x and j weakly converges to x. And set j be a subsequence of x and j, then surely the set j weakly converges in x. Isn't it? X and weakly converges in x. Moreover, x and j, what is x and j? X and j be a subsequence of x and. So clearly this x and j weakly converges to x. But what about set j? We know that set j be a subsequence of x and j. So from here set j weakly converges to x. Okay. So set j weakly converges to x and x. Then y dash f of x equals. What is y dash of f of x? Y dash of f of x equals limit j goes to infinity y dash composition f of set j. Okay? That equals y dash into y dash limit j goes to infinity f of set j. But what is f of set j? F of set j, that equals f of set j goes to y in y equals y dash of y. Means y dash f of x equals y dash. Y dash f of x equals y dash y means y dash of f of x minus y equals 0 for all y dash following y dash. Okay, so that means f of y equals f of x. This equals 0 means y dash of f of x minus y equals 0. Y dash should be the dual. So only possibility f of x minus y equals 0. That is y equals f of x. That's a contradiction. This contradiction is due to our wrong assumption. Therefore, surely f of x then converges to f of x. So this is the proof of that result. Okay. And also, another result holds there. Suppose x and y are non-linear, non-less spaces. If x is a reflexive, we know what is reflexivity. X is reflexive. F of x then goes to, if x is reflexive. If x is reflexive, f of x then goes to f of x. F of x then goes to f of x in y. Whenever xn weakly converges to x in x, then f is in CLXY. This is another result. F is in CLXY. How to prove this one? Here, in order to prove f is in CLXY, we can find out a bounded sequence in x, and if f of xn has a convergent sequence in y, then f is in CLXY. Okay, so far we choose an xn, sequence xn, which is bounded in x. So it means there exists some alpha positive such that norm xn less than alpha, where n equals 1, 2, 3, etc. Agree? When x is reflexive, then every bounded sequence in x has a, we know that by the reflexivity, since x is reflexive, so every bounded sequence in x has a weak convergent subsequence. Okay? Xn is in x, norm xn is bound. Xn is a bounded sequence. But we know that when x is reflexive, every bounded sequence in x has a weakly convergent subsequence. So, secant xn is a bounded sequence in x. Therefore, there exists a convergent subsequence xnj which is weakly converges in x, where secant xnj is a secant xnj be a subsequence of secant x. Okay. So secant xnj weakly converges in x or weakly converges to some x in x. Enough? So, by hypothesis, f of xn converges to, but we know that f of xn converges, when xn weakly converges to x, when xn weakly converges to in x, f of xn converges to f of x. So by that argument, when xnj weakly converges to in x, so f of x and j convert this to f of x in where? Why? Because of hypothesis. Hypothesis says that when xn weakly convert this in x, f of xn convert this to f of x in y. So here, since x is reflexive, xn is a bounded sequence, every bounded sequence in a reflexive space has a weakly convergent subsequence. So x and j be a subsequence of xn, moreover x and j weakly convert this in x. So by this argument, f of x and j convert this to f of x in y. Therefore, that means every bounded sequence in x, f of x and that means xn here, f of x and j has f of x and j convert this in y. F of x and j convert this in y, but we know that f of x and j be a subsequence of f of x. So finally, for any bounded sequence xn in x, f of xn has a convergent subsequence in y. So by definition, f is a, by definition what is f? F is in series. So this is what we require. Okay. So chapter 70 is over. Thank you.